Friends, today we will have a talk on biodiversity and eco-sensitive regions in Western Ghats. Uh, I am Narendra Prasad from Open Source Geospatial India, based in Hyderabad. Before we start about our organization, about OSJ India, it's a registered non-profit society dedicated to promote the free and open source GIS tools and of course publicly available geodata. We also want to promote the use of these tools, advocacy, greater amount of advocacy. We also want to localize skills. We can use the in local languages to use tools. We also intend to act as a bridge between various groups, NGOs, and government departments. Also mentor various FOSS-JS, free and open source JS projects by providing resources such as technical guidance, web space, etc. And we also do capacity building in FOSS geospatial applications in various thematic areas. We work in a number of areas from geology, ecology to hydrology and other fields. Uh, Now, this talk is going to be divided into roughly two parts. The part one will deal with biodiversity. What we mean by biodiversity, what are the factors affecting biodiversity, and what are the drivers of the loss of biodiversity, what impacts it will have, and how we use, in the second part, how we use this knowledge to uh, use tools such as geospatial tools for better decision making. Now, we all know that some of all organisms in a given area, in a sense, roughly constitutes biodiversity, but it also can be according to the biologists and situation. We talk about the biodiversity in different levels. We will come to that in a short while. It's a little hard concept to measure because we have so much of confusion in terms of even identification of species. What one may species, people will think it is two species or maybe three and so on. So with the difficulties we have documented so far, at 2 million species today, and but they are estimated to be about together. So then the question comes: where are the now when coming to the ecosystem diversity above the species level, it refers to the number and variety of ecosystems. Again, density of types is important too, and we are talking about same area of land but with differing biodiversity and ecosystems. Now, of this, the insect rule, the so-called insect rule, is that it's accounting for more than very substantial amount of biodiversity that known to us, followed by we also may find many more bacterial species and other smaller life forms. Now we talk about the diversity, biodiversity in terms of ecosystem diversity and genetic diversity. What is genetic diversity? Is equal to more flexibility to adapt environmental changes. More genetic diversity translates into more flexibility to adapt to environmental changes. That is the number of genotypes if you have. Those genotypes will have the capacity to adopt environmental changes. Uh, like you have in agriculture, for example, rice varieties which can tolerate a lot of inundation, and some varieties which can tolerate a lot of heat stress and water stress and so on. So that constitutes a kind of a flexibility within the genome to adapt to environmental changes. So it's always therefore better to have more genetic diversity. So conversely, the less genetic diversity translates into depressed genetic diversity and therefore less chance of survival because of vagaries of environment. If environmental conditions do not suit that particular genome or variety or whatever you can call, it has a less chance of survival. So the less genetic diversity is always a hazard. And also the genetic diversity is impacted by inbreeding. What is inbreeding? It's mating between genetically related individuals. It translates into less fitness and therefore it attracts more diseases. It's obvious because the inbreeding will not have the advantage of having more genetic diversity. It will have a very localized kind of a thing. So therefore, it will ultimately lead to less fitness by a variety of mechanisms. Okay, we have seen this. Now, extinction loss forever and ever and ever. When we have seen many events of extinction on the face of Earth, this is not the only time we are seeing the increased rates of extinction. And loss of local population is called extirpation. Many species are now going extinct. 99% of the species that ever lived are gone. It's incredible that on the face of Earth, that in this evolutionary history of the Earth, whatever the organisms have evolved in this space, 99% of the species that ever lived have gone. So, in the ongoing process, with one species lost for every 1 to 10 million in existence. So, this is the kind of process, extinction process that we're witnessing. And background rate is a above number. That is, the naturally induced extinction rates are currently, while it is some figure, but the man-made or man-induced things are much above that number, background number. So, what happens if you lose species? The rapid loss of species will translate into mass extinctions. We have seen several episodes of mass extinction on the face of Earth. For example, the extinction of the dinosaurs is one such event. Uh, so we have so far five mass extinction events in the last half a billion years, and about half the species die on Earth, and fifth of those killed, as I said, is about dinosaurs. Last one is caused by man, and the sixth one is currently undergoing what Earth is facing is caused by man and will affect eventually in man too. Now, many species have gone extinct recently, including tigers. Eight subspecies existed earlier, and out of which three are gone extinct, and five are tottering on the edge. Biodiversity has another parameter too. Species numbers are one measure. The other is population numbers of each species. For example, the vertebrates numbers. If you take in African wilderness areas, then the population, the herbivores is much larger compared to conditions such as in India. So they are mostly on the decline. What we have is that these numbers over globe indicate that these are on a decline. Now, therefore, logically, the question comes: which species are on the rise? By one such measure, there has been a 40% reduction in numbers of many species. Uh, we also have a biodiversity loss by habitat alteration. Uh, Habitat alteration is nothing but change of one type of habitat to another. For example, when you degrade a forest, slowly overnight it may not disappear the forest cover, but the quality of the forest decreases, and you have instead of prime tree species, prime herb and shrub species and climbers and so on, you will have weedy species which are not necessarily useful for a variety of organisms. So that is habitat alteration, or even simply you can cut down the forest and plant with you know some species such as teak, eucalyptus, and poplars, and so on and so forth. So it looks green, though it looks green, but in terms of number of species that are adapted to living in the original habitat, they would have substantially changed. So that's habitat alterations. And now we also have the biodiversity loss because of invasive species. Invasive species are the weeds in general, popular you can call that, and we have a number of such things in India. For example, lantana is one, eupatorium is one, and mycenia in northeast of India is one. And many grass species and many weedy species in all kinds of habitats, in wetlands, in forests. You have many of these weeds smothering the regeneration of the native species. So that's how they induce the biodiversity loss. And third important cause is that in the recent times is the pollution, the atmospheric pollution because of human activities. It suppresses the growth, and then also it doesn't promote the well-being of many of the species in all habitats, in water, in aquatic systems. I mean, in forest habitats, and you have seen in a very dramatic way the kind of losses that have occurred both by invasive species and by pollution, man-made pollution, species which are not native to this, like African catfishes in Indian waters. All of that is causing the loss of biodiversity, and pollution because it doesn't allow the all biota to uh, prosper. It ultimately leads to less number of species and less number of species to the loss of biodiversity. And we have also the other cause is the fourth cause is over harvesting. Now we have as humans we have learned to harvest biological resources, not always for our well-being, but for various reasons, commercial, including commercial requirements. We are over harvesting in the seas, in forests, and in all kinds of places. So that's causing driving the biodiversity loss. And fifthly, and more importantly, is the climate change induced loss of biodiversity because of the greenhouse gases. So we have the warming of the uh, atmosphere, which is leading to the loss of species. Now, the human habitat, we'll go into some depth into each of these factors, mainly by human activity, habitat alteration. How are we doing that? Primary cause of reduced by it's supposedly is the primary cause of loss of species in mammals. As many as 85% of the mammals are supposed to be uh, affected by this activity, and birds too. 85% of the bird species are affected by this habitat alteration, the human activity, and these are not gone forever. And we have an estimate that 45% of the forests are lost so far, and about 50% of the mangroves are gone, and coral reefs, about 10% of the coral reefs, and in some cases, maybe 90% of the coral reefs, depending on the geography you're talking about. Now, these invasive species, now we have a variety of reasons why the invasive species are occurring or invading. These are accidental introduction of the species, like I was telling you. The lantana, for example, is one accidental introduction because it was supposed to be very nice flowers and so on, and they were introduced in 1800s, mid 1800s, and we have these kind of, and since then it has gone invasive. Uh, intentional ones. I mean, you have these ones because of importing of food grains and so on. Like with wheat, we are supposed to have gotten this parthenium, the plant that you will see in many parts of the India's rural side, and so you will see that this plant is a good example of the contaminated receiving the contaminated food supplies. So and the economic damage that can be attributed to this is very enormous, and you need to see that, for example, in water bodies, because of these kind of invasive species, the native species are lost. So therefore, you will have loss of for the fishing folk and so on. You will have a lot of damage. And however, quite a few still perish, but some out of which some few thrive too. The pollution, it's not as devastating as the previous two, but the increasing amount of air pollution, water pollution, soil pollution, which are mostly man-made, is driving the loss of species. Now, as I said earlier, these factories, over-harvesting factories, are dependent upon the lifestyle of the hunted. Organisms few in number and with long reproductive cycles and few offsprings are at risk. Some which are, with a low turnover rate of life cycles, that means long lifespans, they're under risk. Uh, Maybe fish and things which have got higher rates of turnover, they may not get affected so much. But the ones with long reproductive cycles and very few offsprings, they're at risk. That includes many of the mammals that we know of. Climate change, man's activity and use of fossil fuels is having an effect on the environment. As I said, the GHG gases, increase of GHG gases consequent to the industrial revolution, and driving the temperatures to be on the higher side, and consequently changing weather patterns. We are all seeing this, the extreme patterns of weather, and then caused by the air and ocean currents, melting of the ice shelves, and then of course affecting the plant growth and leading to desertification. So why is this loss? The primary drivers of this biodiversity loss can simply be attributed. If you look at just about a couple of 100 years, now this is what uh, we have witnessed: the population growth and their increasing standards of life, and then consumption. This is increased consumption are primarily responsible for increase in loss of biodiversity. Compared to say 2 or 3, 4 generations ago, the consumption story is very high. I mean, consumption story is driving the loss of forest, loss of aquatic biodiversity, and so on. So, these consumption patterns of humans is one major driver of biodiversity loss. So why care? Why should we care? I mean, it's okay, biodiversity is losing. So we're not saying that humans are getting lost, but then how should we? Why should we matter? Does it matter if just humans and their food supply remain? We may say that with all the chemical fertilizers and insecticides and so on and so forth, we can manage. So why should we bother? Uh, that kind of superficial understanding is because we don't understand what the various ecosystems are providing us with, what kind of services they are providing us free of charge. They are not charging us for providing us clean air, fresh water, uh, buffering systems against floods and drought, and then reservoirs of genetic variation and a lot more at no cost. Because these natural ecosystems provide all these ecosystem services, including the goods which we have taken for granted. We are not observed. I mean, nobody's giving us with the cost, clean air, fresh water, and so on. We are taking it for granted, and These are the services, ecosystem services that will accrue to societies if they conserve biodiversity and the habitats and so on. So this important factor one should always keep it in mind before we ask that question: why conserve? Why should we bother about conserve? This is the message one should go. It should go across to all sections of the society. And more like drugs, the ecosystem services includes drugs that the plants provide, treating ulcers, medicines, anti-cancer compounds, and then of course the values such as tourism. Ecotourism is one major thing benefit. We all know that if the countryside is very well preserved with all the animals, wild animals, and so on, how ecotourism is a major economic driver for many countries and many societies. So that's the kind of service ecosystems provide us, and uh, and better solutions in translating to better sweeteners for human beings, not for anything. And then biophilia, and then the connect, the affinity to nature and organisms, which is biophilia, and we connect to the nature. Mm. Now, this is all about what we I intend to talk about general, what we know about general things about biodiversity and the factors affecting the loss of biodiversity. Now, how we can apply this geospatial tools, and especially open source geospatial tools, which is the focus of this training, to one of the hotspots of biodiversity in the, not only in India but also globally, Western Ghats. Some years ago, we had a chance to look at the ecological sensitive areas in Western Ghats using the publicly available data. This was done for the Western Ghats Ecology Expert Panel, I think about roughly a decade ago. So I would just like to showcase this as a case study. Now this is how the Western Ghats are there. If you see the peninsular India, if you have this map of our peninsular India, starting from Gujarat through Maharashtra, then you have Goa, then you have Karnataka, and then Tamil Nadu, and then Kerala. The Western Ghats are spread over an area of from about 1600 kilometers from north to south, with a narrow strip actually. It's not a very big one. But this mountain range, the range is so very crucial uh, because it supplies water. The rivers, important rivers, many important rivers originate in this: Krishna, Godavari, Kaveri, all kinds of things. And then, of course, many west flowing rivers, they take the origin from this Western Ghats, because the monsoon led clouds, they hit the landmass here, which is above this sea level, going up to maybe about 2,500 meters or so. And then when they encounter, the clouds encounter this kind of barrier, physical barrier, they unload all the moisture, and that's how you get very heavy rainfall here. And in fact, uh, India's second highest rainfall area is in Karnataka, a place called Agumbe. So this is in a sense, this is serving we just seen in our previous part, ecosystem services. So the hydrology, water resources perspective, even just from a water resources perspective, just take only one aspect of that ecosystem services. It's very very crucial. Now this is also true for forests and wildlife and other, therefore by implication all other biota. So this is the kind of biodiversity that this particular region has, and Himalayas is next another major hotspots of biodiversity in India. And this is actually showing the kind of elevation that we have in the Western Ghats. This is classified into, color coded into different kinds of things. The bright red is above 1500, blue is between 1200 to 1500, light blue is 800 to about 1200, 900 to 1200, and so on. So this kind of categorization of the terrain is possible to using the SRTM, that is Shuttle Radar Topographic Mission. Now we have seen how the elevation, the digital elevation models are derived from the topography and so on. So this is from satellite derived data. The elevation has been derived in this. Okay, this is the why should we use for this kind of exercise for prioritizing our conservation areas or determining the eco-sensitive areas. Why should we think of free and open source tools? We can use all geospatial tools, including proprietary tools. But if you use these free and open source tools, it lowers the access cost to geospatial software for inventory maintenance of spatial databases. Now, proprietary software, geospatial software, is very expensive. Not many institutions and individuals can afford to have it for themselves. Uh, Therefore, this free and open source geospatial tools lowers this access to the cost of geospatial tools, both in learning as well as in doing your own project. So, and then of course, it allows you the enhancement of research and teaching in applications of biodiversity research. It's not only biodiversity, but even agriculture research and even agricultural engineering and so on and so forth. It will have a lot of scope for both in research as well as in teaching. And then, of course, in a wider project-based kind of a thing, activities, research and development of spatial in R&D activities and spatial data infrastructures, and therefore it needs the need for more transparency of your data and accessibility and long-term sustainability of these databases is a concern for this. Now, having seen this, now we will see the GS applications in ecologically sensitive areas, not only for Western Ghats, but it can be for any other areas in Himalayas, in Eastern Ghats, and various other areas too. So for this, we had used some kind of novel approaches. What we have done is that in parameter generation, we need a lot of parameters, both physical as well as biological parameters. So we generated first slope map in native format using GDAL library and uploaded all the data sets into database. And we have seen this SRTM data just in the previous slide for the entire Western Ghats, elevation values from the SRTM data. And then we have calculated, because you have millions of these, what do you call, cell pixels, we actually put them in a 5-minute by 5-minute grid, which translates into approximately 9 kilometer by 9 kilometer. So you may say that this is a very coarse kind of a thing, but we were dealing with at the time very large area and to very time specific, very narrow time period, gap of time period. We needed to generate that. So this is operationally this was found feasible 5-minute by 5-minute grid. And this is how I'm not going into all the details of that, but I'll just tell you the kind of results that we got in this process. We had also in other parameters biological. I'm not going to the details of that. So that is including the mammal species diversity, then the weeds. We have seen in the previous one invasive species and all kinds of based on those parameters. This has been generated. Amphibians, fish, reptiles, birds, mammals, all of that, their abundance and their occurrence, they all has gone into each grid 5-minute by 5-minute grid in terms of how they are represented in this. So through this, we had actually generated these color-coded things. Now, now the ones with 8 and 7 and so on, they're actually quite high in terms of sensitiveness, because the values from the various parameters are quite substantial in this. So therefore, This is how the entire area is gridded. This is for Maharashtra, and these are the results of this. So the higher the numeric value in this, the sensitive, the greater the sensitive that particular grid is. Now, similarly for Karnataka, you have this kind of grids. So all of these blue ones are the ones with higher scores for something like. These are also happens to be the crest of the Western Ghats. So naturally, the crest of the Western Ghats, even now, if you can go into the field and see, is all very rich areas for not only for forest but also wildlife and so on, including elephants and so on. So forth. So now, when we have this kind of data, now how do we make it available to people? So we had when we had this project at its height, we had organized this kind of a thing. Currently, this may not be available, but this is how we can organize the spatial databases. This is Western Ghats Spatial Data Infrastructure, Western Ghats Biodiversity WebGIS. This is various kinds of things, endemic species, and then plant species, and so on and so forth. And this is how you can do that. Now, once we have this kind of a thing on mobile, anyone can with that access. Anyone can actually access this data and understanding, try to get understanding of the distribution of various species and so forth. Now we'll come to the other important aspect of geospatial data collection, which you probably would have attempted in your first 2 days of training, is the geospatial OpenGIS on Android things. So we use Android phones to collect the data. We used one particular app. You've seen that. We have so many other things. QGIS, of course, you used, and then these are all some of those apps that one can use. Now coming to this, now the government itself is government of India itself has got a open source policy in Digital India Mission. Way back in 2004 itself, they started this as it has they professed into open source policy on Digital India Drive to cut the software costs, as explained. And this is how the society is going to travel towards the digital uh, India drive. Now, if you go into the other kinds of things, you can the freshwater biodiversity, FWBD, international agencies such as IUCN, International Union for Conservation of Nature. Freshwater biodiversity is facing unprecedented levels of threat and river and so on. We will not go into much depth into this. Uh, Now, OSGeo offers it's a good it's a worldwide kind of NGO participation in terms of education, providing resources for education. This is provided in the OSGeo live DVDs, CDs, etc. Now, of course, CDs are not too much, but we even USBs you can use it, and through this kind of a medium, that is every year, every 2 years or so, globally, FOSGAS is conducted, FOS for G, what they call. Uh, these conferences allow you to see what is being done on various fronts, themes of interest, lectures, and in summary, I would like to say that the open source geospatial tools hold tremendous importance and significance for student community, especially to learn and then experiment, and then also you can, since you have got access to the code, you can actually look into the details, what modules work and what don't, or you want to add up your own particular thing, you can do that. You can localize your own thing. You don't like to speak only in English or access it in English, you can do it in Hindi or whatever regional language. uh, so I just showcased one example with biodiversity, how one can use it, and how you can help society in in taking care of its natural resources. Thank you. I finally thank Meher Baba for giving me this opportunity to talk to you guys.